now I would now show you how the criterions actually work, right? That is also a key feature. So first, what I'm going to show you here is called as the SSS, side. So how do I represent this? This is called as side criterion, right? So what is the meaning of this? Say suppose you have, say, two triangles, say A, B, C, and you got P, Q, R, right? And if AC has the same side as PR and BC has the same side as QR and AB has the same side as PQ. So clearly you can see that the sides are matching each other. So when you're writing it, you can clearly state here is, we observe that AC is equal to PR and then BC is equal to QR and then AB is equal to PQ. So this means by SSS criterion we can conclude triangle ABC is congruent to triangle PQR, right? So this is the first one which we have seen. Let's move on to the second one. Now students, we will look into the next criteria. This is criterion number 2. It's called the side angle side criterion. So let me write that down. Side angle side criterion. So by this criterion we can outrightly state if two triangles are congruent or not. So suppose you have triangle like this, right, and another triangle like this. So this is A, B, C, and this is P, Q, R. So you got a side here and there is a side here, and you got an angle like this, and you got an angle like this, and you got another side like this and another side like this. So clearly on observation we see that so what do we see? AB is equal to PQ and also angle B is equal to angle Q, followed by BC being equal to QR. Hence by SAS criterion clearly triangle ABC is congruent to PQR, right? Make sure to place the triangle symbol. So with this we will move on to the next criterion. Now the next criterion is ASA, or also called as ASA criterion. So this is nothing but angle side angle criterion. So what are the criterion states? So suppose you have a triangle like this, right, and you got another triangle like this. So this is A, B, C, P, Q, R, and you got an angle here, an angle here. So this angle is same as this angle, and then you got a side here, you got a side here, and then you got another angle and an angle here. So angle on observation we see that. So what do we see? We see that angle A is equal to angle P and side AB is equal to side PQ, also angle B is equal to angle Q. So this means by ASA property, triangle ABC is congruent to triangle PQR, right? So let's move on to the next one. Students, this is the next criterion. It's called as angle side. Let me state that angle side criterion. So how does it feature? So just imagine you have a triangle like this, and you have another triangle something like this, right? So this is ABC, this is PQR. So you have an angle over here and an angle over here, both of them are same, and you got another angle over here and another angle over here, and then you have a side here and you got a side here. Now the way in which these triangles are oriented can be different. Say for example, instead of this triangle being like this, it can be like this. Right? Say A, B, C. Now in this case you have an angle here and another angle, and then BC you got a side here, but still this can be compared with this, so have that in mind. So your check should be angle, or angle, and then immediately the side comes into play. So that should be the case. So in this case, on observation, you can state it like this. On observation, we have, so what do we have? Angle A is equal to angle P, angle B is equal to angle Q, and BC is equal to QR. Thus, by angle side criterion or criteria, we conclude, so what do we conclude? We conclude triangle ABC is congruent to triangle PQR. So this is the conclusion. So we will move on to the next criteria. So this is the next important criteria. It's called as RHS. So that would be right angle, hypotenuse, and side criteria or criterion, right? Right angle, hypotenuse, and side. So how does it actually come into play? Imagine you have a triangle like this. Okay, this is A and B and C, and this is the right triangle, and you got an hypotenuse side over here, and you got another triangle like this. So this is PQR. You got the hypotenuse here. This is the right triangle or right angle. Now along with these, the angle and the side, we need to have, or I should say along with the angle and the hypotenuse, we need to have one more component, which is the side here. So in this case, if this side is the same as this side, or if this side is same as this side, then we can easily conclude. So upon observation, we can make the following justification or following conclusion. So let me state that upon observation, we see that angle at C is equal to angle at Q. It's a right angle, and the hypotenuse side AB is equal to PR, right? the hypotenuse sides are equal. Also, BC is equal to QR, right? So this is the right angle at C and angle at Q, and this is the hypotenuse, and this is the side. So right angle, or I should say right angle followed by hypotenuse and the side, RHS. So by RHS criteria, we conclude, what do we conclude? We conclude triangle, you can start it in any way you want. I want to start it as BCA is congruent to triangle PQR. So that is what we call it as RHS. Let's do this question, students. So this is question number 1. We have been given 2 triangles. Okay, so it's a triangle there, and then you got a triangle here. So this is EFG and M and O, right? So you got, say, 3.5, and you got a triangle there, you got a 5 here, and 3.5 there, and you got a 5 here, and you got an angle here, and this angle is given to be as 105 degrees and 105 degrees. So we are expected to check if triangle EFG is congruent to triangle MON. This is the check. So what are we going to do? We will have to include the criteria that we have studied, right? So we will have to justify by what. So that is a key part in this. Now, upon observation, so I'm going to, this is a solution. This is the way you need to write the solution. So upon observation, right, this is a scientific approach, this particular terminology. So upon observation, we know that. So what do we know? We know that, or you, instead of saying we know that, you can use your vocabulary that you would like. So clearly we see that EF 3.5 is equal to, you have a 3.5 here, MO, and then comma, what do you got here? Angle F is equal to angle O. Along with that, FG is equal to NO. So what you can derive from this, hence, by invoking, what is that criteria you're going to invoke? You're going to invoke side angle side criterion. We conclude that triangle EFG is congruent to triangle MON. So that's the solution, right? So you will have to write the following steps to complete the solution. Students, we have a beautiful question. Let me state that question. This is question number 2. If triangle ABC is congruent to triangle XYZ and given AB equals 5 units, find the length of, say, XY. What can you say about XY? So this is what the question is, right? So what would the solution be? What would XY be? Say for example, you have this triangle A, B, C, and you got X, Y, Z. We've been given AB is 5 and both the triangles are congruent. We are asked to find what is XY. We need to know what is XY. So what would your solution be? Now clearly XY will also be 5. Now how do I say that? Now there is a theorem. It's called as CPCTC. Okay, you can state it as a theorem or you can state it as a rule. So what the rule states? This is nothing but, let me write the abbreviation. It's expansion. So it's called as corresponding paths of congruent triangles are congruent. Corresponding paths, CPCTC. So the corresponding paths of congruent triangles are congruent. So the corresponding paths, these two triangles are congruent. So the corresponding paths of the triangles are congruent. So AB is 5, then XY will also be equal to 5. So that is the conclusion for this beautiful question.